Today we will see about relations. Okay, in the earlier classes and all, we saw the set. Okay, and we saw many things, right? We saw the sets, union of sets, intersection of sets, and lot many properties also we discussed, right? So the next thing is the relations. That's the relations between the sets. Two sets you are giving a set. We saw the union, everything we saw. Given two sets, is there any possible? What are the possible relation between two sets? And this is a very important thing in the mathematics. Okay, so you will when you are dealing with the numbers, you have to have the relation between the two sets. Okay, I can give you one immediate example. Okay, what I can give you immediate example is, you remember the coordinate system. Am I right? This is x. This is y. Can you tell me the x? If I call the x in the form of a set, I'll call it as a. Can you tell me what is a? X such that
X is the x for x axis.
x is an x. What is that? X is an x element of real numbers.
Okay.
Am I right? If I ask you, can you write the x coordinates in the form of a set? This is what you will write, correct? And then if I cause y in the form of set, what you will write? B equal to, that's also x. X is an element of R. Okay, they both are equal sets, correct? In our case, we are getting equal sets. Okay, so this is a simple example I am saying. So now, what do we mean by relation between these two sets? Okay, so you can see all points in this space can form the sets, right? So I give you a point. Okay, so let this point be 1, 2. Okay, so it is what you have done. You have taken 1 from the set A, correct? And 2 from the set B. Similarly, you can have another one point. A, comma B. What it says, you have taken A from set A and B from this set B. Okay, so you can write some other point, alpha, beta. For alpha you have taken from A and beta you have taken from A. Okay, so this type of pairs. Okay, so the pairs which you taken from the two sets and writing as a pairs, these types of pair is like this, all these pairs you can have, right? So that alpha, anything number, you can have something around 5, comma, what do you call 5, comma 2, whatever it is. Okay, so this is what you call as your ordered pairs. Okay, the ordered pairs is what? A pair A comma B of numbers. What written this pair? Okay, they written as number A comma B. A pair A comma B of numbers, okay, such that the order in which the numbers appear is important. Correct? This order in which number appearing is important. And not just that, you can't reverse it also. They won't be same. For example, 1 comma 2, will 2 comma 1 be same?
No.
It's a different point. You got it very evident from the graph, you can find. Okay, so where the order is also important, such that A comma B is not equal to B comma A. Yeah, sorry, are not equal to B comma A. Or different, I would say not equal to, they are different. There's something like equal to, we are writing a set, pairs, na? Or different. Okay, so this type of group of numbers is called as your ordered pair. Okay, ordered pair. Okay, and that's right. And then okay, this is some A is called as the first component and B is called as the second component. Here you can call X component and Y component. So X component is first one. Okay, it's not always to go only with the graph. This is an easy way I explained to you because you have done all those in mathematics. Other simple example I can give you is, so for example, there are in a very day-to-day example. There are 3 boys and 5 t-shirts, 5 color t-shirts. So what are the possible way you can, the boys can wear? They can pick up any shirts and wear. Okay, so what we'll have something like that. Okay, let me take the boys, or let us give the name of the boy as the set 1, which is a set of the boys. Let the boy be A, comma B, comma C. And set B is the color of the t-shirts. So let us call it as green, red, yellow, blue, white. Okay, 1, 2, 3, 4, 5. So here also you can form ordered pairs. Am I right? Because A can wear green or blue or red or blue, anything. And similarly, B also can wear anything. C also can wear anything. Okay, so we can actually form a set of ordered pairs. Am I right? So now what it says is the okay, one of the order pair you can write is A comma green. Okay, or B comma white. So these are also ordered pairs. It's not necessarily you have to do it in the coordinate system. Okay, there are many examples like that we can do. And now, okay, yeah, they given one example, one problem. Okay, so in general, what is that? As I wrote it here, A comma B is not equal to B comma A. Okay, if on the other hand,
If A equal to B.
Yeah. Okay, yes, correct. If A comma B is equal to B comma A, B comma A, that means A equal to B. Okay? And similarly, the other one property also we can say, suppose for example, A comma B is equal to C comma D, it means A equal to C and B equal to D. Okay, so this is the way the order pair you can find. So they gave one example, one problem. So find x and y when x plus 3 comma 2 is equal to, this is one ordered pair, equal to 4 y minus 3.
X plus 3 equal to 4 and
Correct.
y minus
So
3
x plus 3 equal to 4. This gives you x is equal to how much?
1.
1. And y minus 3 equal to 2, and this gives you 5. Okay. Am I right? Right. So this is the one. So now, this is what we have done. Okay, let me take back the problem again. Okay, so this is a font. Well, let us write down the same problem what you have done. There are how many boys? 3 boys. Okay, so let the set A be, what are the boys we said? A comma B comma C. Am I right? And B is the color of the t-shirts. Green, blue, yellow, what is that? Red, okay, and white. Correct? 5 color t-shirts. Now, there is something called as the Cartesian product between the sets. What is the Cartesian product between the sets? Take out all the possible ordered pairs. When you take all the possible ordered pairs, that's what you call as your Cartesian product of sets. Okay, so can you tell me what is the Cartesian? So, a symbol is A cross B will be, can you tell me?
Green.
A comma green, and it is capital G. Okay, A comma G, A comma B,
A comma Y,
A comma Y,
A comma R,
A comma R,
A comma W,
and then A, oh, sorry. Pairs, na?
B is also
I have to use that normal bracket. Yeah. A comma G, A comma B, B, A comma Y, A comma R, A comma W, okay,
B
and
comma
then
B.
same thing like B, am I right? B comma G, it go on, and then C, and this, and then that's it. Correct? So finally you have the okay. Okay, so this is what. Okay. Similarly, you can find it for the numbers also, but here it will be infinite because this is infinite sets. Okay. Can you tell me when I do that? So what will be your n of A cross B product, Cartesian product of B here? How many elements will be there? Can you tell me?
A into B, right? The number of elements in A into the number of elements in B.
Correct, correct. So let us say, what is n of A?
3.
3. What is n of B?
5.
Equal to 5. So of course 1, 2, 3, 4, 5 into 3. Okay, so it makes how much?
15.
So we got it. So simple, one relation already we got. N of A, n of Cartesian product of AB will be equal to n of A into n of B. Clear? So that's an interesting property. A simple property, we got it. Okay. Okay, there are some problems. They given A equal to 1 comma 3 and B equal to 2, 3, 4. You can actually find out. Okay, find the number of elements in the Cartesian product of A comma B. Okay, this is simple. So what they are given is, you understood, this is the way the ordered pairs can be formed. They are not complex. Okay, simple. So first of all, the ordered pairs you have to form. Okay, and then only you can go for the relations. I will come to relations, what we mean by. Okay. Well, so the example what they have given is, say they given A is equal to 1 comma 3 and B is equal to 2, 3, 4. They are asking what is n of A cross B.
That will be n of A into n of B. That is n of 2 into 3.
Correct. Okay, so that's all the one. Now, can you tell me, suppose your Cartesian, if your A is a null set or 5, am I right? And B is also a null set. Can you tell me what is A cross B?
1. N of A cross B will be 1, right?
N of A cross B will be 1. What is A cross B?
So that will be 0.
0 null set. Am I right? That will be 1. Okay. Fine. That's right. No, n is 0.
N will be 1.
Come on, this is 0, na? Null set. What is the number n of null set?
Okay.
Number of elements in null set is 0. How it become 1? Okay. Okay, fine. And okay, now this other thing is Cartesian product of a set with itself. Can you give an example? Just now I did an example. Okay, let us do for this one. For example, let us take for A. Okay, so let us take this one.
A comma B and B comma A.
Okay. What do you write? Oh, okay. So A is equal to A comma B comma C. Can you write down its Cartesian product of itself? What will be? A. Okay, which written as A square also. Okay. Tell me A comma A.
A comma B, A comma C, then B comma A, B comma B, B comma C.
And similarly C comma A and C comma B and C comma C. Okay. So it's a kind of the same thing. Now this is also, both are equal sets, right? A and B. So whatever the Cartesian pairs, basically we're taking from the equal sets. Okay, fine. So this is what. And can you tell, okay, so how do we represent A cross A? A square in a set builder form, that will be what we write. Okay, they written it as pair of A comma B such that A comma B is an element of A. Got it? Or you can write XY also. If you don't like, since I written A comma B, you write it as XY. Let us write it as X comma Y such that X comma Y is an element of A. This is a Cartesian product. Okay, so this is an order. And there's something called as what they have done. There's another one which is there, which is normally don't use it. Okay, what is a Cartesian triplet? Say triplet, ordered triplet. Okay, so when you have A cube is equal to what? A cross A cross A. So what will you do? You take this one. These are all the elements, and multiply with one more A. So what will you have? So this will be your X comma Y comma Z such that X comma Y comma Z is element of A. Okay, so this is called as ordered triplet. Okay, fine, and that's it you have. And then there is one interesting property. Okay, and this is also very simple in a triplet. Okay, what will be n of A cube? Can you tell me? If n of A equal to, here we have written n of A equal to, say something, n of A here is how much? 3. Equal to 3. So what will be n of
A square.
N of A cube?
3 into 3 into 3.
Correct. So what is that? 3 into 3 into 3. How much?
27.
27. So now let us say, okay, so now we are having, suppose n of A. N of A equal to, say, m.
Okay.
What is n of A cube? M cube. Am I right? So n of A cube is equal to n of A whole cube. Okay? That's how you write down the property. Okay. Now coming back to, okay, so basically what happened, given any two sets, we can always form an ordered pairs, right? So one example is that your axis, coordinate axis. The x is a one set, y is another set. If you can form the ordered pair, they are nothing but the coordinate points in the space. Okay, so they are infinite sets. Now, other thing is, so let me go back here. Okay, so here's an infinite set of ordered pairs I have. Correct? Because they both are infinite. So now, can I define any relation between a set of points? For example, okay, let me take it up. Let me put up one ordered pair, which is 1, comma 1, another ordered pair 2, comma 2, another ordered pair 3, comma 3. Can you find out any relation between them? A equal to B, which is nothing but a straight line passing through the origin. Okay, with a slope 45 degree, right? Slope. Okay, fine. So this is a 45 degrees. Okay, so this is, and so what happens? So all the ordered pairs falling on the line, they are related. They are not arbitrary. Correct? They are related. So that's what you call as the relations between the two sets. If two sets, they are somehow related, then you call this is what you call as the relations between the sets. Okay. So what they written is a well-defined relation between the elements of A and B. Okay, that's what relation is given by what they represent is, suppose for example, we are having two sets. Say, let us call the sets as you are, say something like your A and B. Okay, and the elements of A let me represent as A and B represent as B. Okay, so what we have, so if A and B are related, so and we will write that symbol as A is related to B. R is for the relation. Okay, so a well-defined relation between the elements of A and B is given by A or B. That is, A is an element of A and B is an element of B. Clear? Thus, the relation gives ordered pair AB. Okay. So, therefore, when I say a relation, the relation also will be an ordered pair. Am I right? Based on some relation here. So, all these points on this line, they are also ordered pairs. Am I right? They will be a subset. Okay. So, take all the relation pairs. They will be a subset of the Cartesian product. You got it? So that's what the point is. That's what you mean by relation is. Okay. See, for example, okay, they are given a very nice example. Simple example they are given. Okay. For example, say they may be differing by a factor. So for A, I'm taking the same example in the book. 2, 3, 4, 5, 6. Okay, and B equal to 6, 7, 8, 10. Okay, here I can form an ordered pair. So let me call the ordered pair as let me call it as S. Correct. Yeah. Your book they missed many things. Okay, so you also tell me, are they related? What is their relation? Okay, 2, 6, 2, 8, 2, 10, 4, 8, and 5, 10. Oh yeah, sorry, 3, 6 is also there now. Sorry. 3, 6, 4, 8, 5, 10. Can you tell me what is the relation?
The last three parts you can put like A equal to 2B.
Okay, simple. That we got it, of course. Tell me from here also. Nothing. What the relation I written is A is a factor of B. Can you form? Okay. So I created a relation. So this is the pair set from the relations. Not just that. Once if I have defined this, okay, and now what you see, so S, the pair S will be a subset of A cross B. Am I right? And so once I given this form, so I can still go through more. I can even write one more S prime, say something other. Actually, I shouldn't write it as an say some other. Some S prime you are using for complement. One shouldn't use that. Actually, I know they are using S prime. Say some other. P. Okay, you want to write T? T. I can write it as 2, 7, 3, 7, 3, 8, 3, 10, okay, 4, 7. Tell me, another one is 4, 10. Okay, we can write. What I say, they are not a, when I write is a factor, is not a factor. Okay, you can write that way also. And they have, means, okay, and the other one also they have. Okay, this is another thing set they have given. For example, okay, I can keep doing on like this. Okay, I am not finishing it out. R, no, I will not write R. P. Can you tell me what is the relation between this set? 2, 7, 3, 10, 4, 7. So this is a P is a subset of A cross B. Can you tell me how I got this? Simple. The common factor will be 1. That's it.
Okay.
Correct. That's what we did, na? Common factor is 1, right? Yeah. But anyway, we can write 3, 7 also. I know it's not complete. 3 and 7 also we can write. Okay, I don't know why they wrote this set.
But if you can take common factor as 1, then all the numbers, any set can be a relation, right?
What is that?
If you can take common factor as 1, then any two sets can be a relation.
Only 1.
Only 1.
Common factor is only 1. Okay, that's fun. Anyway, this is not fully correct. We can add up more also, because what we can have 2, 7, and that's it. In 3 we have 3, 7 is also there, na? 3, 7.
2, 5 is also there, right?
5 is, where is 5 here?
Oh.
3, 7, and then what I wrote?
What about
3,
5, 7?
5 is there. 3, 8 is also there, and 3, 10 is also there. 4,
7.
6 will have common factors.
7.
4, 7.
Only that.
Yeah, and 5, 7, right? 5, 7. Of course, 5, 6 is also there.
5, 8.
5, 8 is also there.
Then 6, 7.
6, 7. 6, 8.
6, 8 has a common factor 2.
Oh, yeah, right. Correct? That's right. So we can write the sets like that. So basically, that's why you can define a relation. So what it says is, for every, okay, and whatever the relation you say, this is going to be a subset of your Cartesian product. Okay, A cross B. So for every relation between A and B, there is a unique subset defined in A cross B. Okay, there will be, because see the point, when I look back in the Cartesian, okay, so this is a straight line. This is a one relation I wrote, the points on the straight line. Why will be a straight line? That can be a kind of a circle. This is a relation, falls on a circle of radius r. Okay, that's also a kind of an what do you call relations. Okay, and they have a ordered pairs. Okay, and that will be a subset of the Cartesian product of x and y. You got it, nah? So this is the way we can define thing. And there's another thing, and this is interesting. This comes here. If you find a relation, if A equal to B, if two sets are equal, where you have this set is equal, na? Your x-axis is again an element of R. A and B are equal, and there you are defining a relation. Okay, and that you call as when the both the sets are equal, when you form a relation between them, that you call as a binary relation. Okay, for example, these all are binary relation because they are both the same sets. You got it? Huh? When A equal to B, that is when we have a relation between elements of A that with a subset of A cross A. Okay, and if A is non-empty. Okay, any relation in A cross A is called as a binary relation. Got it? Fine. So there are okay, then there is one arrow diagram. Let me show it out. Okay, fine. Oh, okay. So let me take up an example. We can draw this arrow diagram also. Okay. So what they have is they given a set A which is 1, 2, 3, 4, 5. Set A is equal to 1, 2, 3, 4, 5, and and set B 1, 4, 5. And the relation is, what the relation they given is, let R be a relation such that R be a relation that okay, I don't know, they use the same symbol. I guess what they mean is x comma y is an element of R. I don't know what they mean. Yeah, okay, the relation element x comma y is an element of R implies x is less than y. Can you tell me what is the R will be? What is the relation?
X comma y is an element of R.
Correct.
Y is greater than x. Y should be greater than x.
Tell me.
Okay. So in y we can take
A. This is A.
1 comma 5.
1 comma command. Start from 1 or 1 comma 4.
1 comma 4, 1 comma 5. 2 comma 4, 2 comma 5. 3 comma 4, 3 comma 5. 4 comma 5.
That's it. Right? 1 comma 4, 1 comma 5, 2 comma 4, 2 comma 5, 3 comma 4, 3 comma 5, and 4 comma 5. Okay, so this is what the relation is. And there's the arrow diagram. What they do is the arrow diagram. Okay, so what it says is the A is related to B, like that. Okay, there's a word, what they call, I forgot. And the way how to write is, you need to know how we will, because the next one you say. Okay. R is a relation from A to B. What you mentioned is R is a relation from A to B. Okay, so the way how to draw the arrow diagram is kind of a Venn diagram. What you do is, let me do that. So let me take out, let us represent the set A. Okay, set A how many points? 1, 2, 3, 4, and 5. Okay, and let us have the other set B, which is what? 1, 4, and 5. Now, can you draw the relations? So 1 is connected to 4. 1 is connected to 4.
1 is connected to 5.
1 is connected to 5. 1 is connected, oh, that's it. 2 is connected to 4. 2 is connected to 5. 3 is connected to 4. 3 is connected to 5. 4 is connected to 5. And that's it. Correct? Yeah, that's what your Arrow diagram. Basically, you have to write down all the, forgot to write. You have to always mention the arrows. Okay? This is that's all your thing about your binary and relations. Okay, this is simple. Okay, why this will important is because then you will see when you have two functions, how we are going to map a function, all those later on. This is only the basic concept they are giving, the sets and everything. Okay, and there are two other terms which I introduce and then I leave it. Domain. Okay, what do you mean by domain is, domain is a set of all the first component of the ordered pair in a relation R.
Like in that 1, 2,
1,
3,
2, 3, 4. That is a domain. Okay. So don't write 1, 1, 2, 2, 3, 3 because we don't need a repeating, right? So your domain, let me call it the D. Here it is 1, 2, 3, and 4. Range. Can you tell me what is the range? Second one. Okay, so range is what is in the second component.
4 and 5.
Range is what? Let me, I don't want to call that. Let me use a curly R. What is that?
4 and 5.
4 and 5, yes. The range is a set of all second components of all ordered pair in a relation, or is called the range of the relation. Okay. And then there is something called as codomain. Codomain is what? If R is a relation from A to B, okay, R is a relation from A to B, then the set B is called the codomain of the relation R. You got it? So if R is a relation from A to B, then the set B is, oh my god, something. See, this R, if you draw it like, write it like this, they'll cut mark. If R is the relation between A to B, then B is called as your codomain. Okay. Now you can see the range will be a subset of codomain. You got it? That's it. Okay. So I will stop here. Tomorrow we will try to study the binary relation on a set. Okay. Some of the relations we will study about it. Okay. Yeah, we will do some relations and some types of relations also we will discuss. With that, this chapter will be over. Okay.